Thank you very much. It's lovely to be here, and I'm looking forward to the conversation. So I've framed my talk really using the leverage points framework, which Donella Meadows published in 1999. For those of you that were at the first cafe, it's something that Michiro referred to. For those of you that don't know, the this is a hierarchy of intervention points for leveraging change. So Meadows argued that the transformational capacity of a given intervention depends on the characteristics of system properties. So it's systems thinking, and some interventions are likely to cause transformational change, while others will only lead to minor change or outcomes. So she ranked these 12 intervention points from shallow ones at the top of the hierarchy, which are easy to implement but have limited impact, to deep interventions at the bottom, which are challenging but potentially transformative. So when I'm thinking about my research, I like to think about, where on this hierarchy does it come? What is the transformative, potential of this research? So I need to keep an eye on the time, but hopefully I'll be able to get through. I prepared three topics to talk about, which kind of zone in on different parts of the hierarchy. So the first is a project about sustainable fish feed, and this was an IRANET co-fund on food systems and climate. The project ran from 2021 to 2024. So development of sustainable fish feed, in terms of the leverage points hierarchy, this would really be classified as an intervention at the level of structure or material stocks and flows. So, quite high up the hierarchy. In other words, not really leading to transformative change. So a shallow leverage point. But if this work leads to new policies or incentives or standards, then arguably it moves further towards the transformative potential by changing the rules that govern the system. So essentially, what we did was we ran some feed trials to explore the partial replacement of fish meal protein, which is very unsustainable in terms of its impact on ecosystems, replacing that with black soldier fly, which are insects, and spirulina, which is a microalgae, or actually, to be really correct, a cyanobacteria. The insect meal we got from a French company who produced their insects in Tunisia on food processing waste, fruit and vegetables, and the spirulina powder was produced in China. So we ran the feed trials, and then we used the results from these trials to carry out 2 life cycle assessments. And we used different functional units. So the functional unit is basically your unit of comparison. So comparing a fish feed made with insect protein and one made with fish meal. So 5 different functional units. One was a ton of protein at the farm gate. So that would be in China or in Tunisia, depending on whether we're thinking about the spirulina or the black soldier fly. A ton of feed, and then the produce. Now we use aquaponics, which I'm sure most of you are familiar with, but if you're not, aquaponics involves growing fish and plants together in a recirculating system. So very simply, the water from the fish tank passes through a biofilter into the plant growing tank, taking with it the nutrients, and these nutrients essentially ultimately originate in the feed. So you feed the fish, Some of the fish feed is uneaten and dissolves into the water or settles on the ground, and the fish, excrete. So the nutrients, as I say, move to the plant growing tanks. The plants take up the nutrients to grow, and at the same time clean the water. The water recirculates back to the fish. So it's very efficient in terms of water, not so efficient in terms of energy, especially in northern latitudes. And so our other functional units then were a kilo of fish, a kilo of basil, and a kilo of chili peppers. We used 2 different kinds of plants, basil and chili peppers, because we wanted to compare a low nutrient plant, which is the basil, with a fruiting plant, the chili, because they need a lot more nutrients to make the fish. And then we compared doing life cycle assessment, see which of the feeds were best. And interestingly, depending on whether the crop that we were looking at was the fish, the basil, or the chili, the results were different. And then, as in all life cycling assessments, you carry out sensitivity analyses to sort of test alternative scenarios. So we experimented with, what if we used renewable energy in the feed production and fish and plant production? What if we replaced soybean meal with other plant-based proteins? And then using the results of that life cycle assessment, we then did what's called a screening life cycle assessment, where we were saying, okay, rather than importing the insect protein ultimately from Tunisia and the spirulina protein ultimately from China, what if we were to make this, on the farm at the Greenwich aquaponics unit at our university, and compare that with a commercial fish feed. And for the black soldier fly, we modelled 2 diets. One is for the very early stage of the insect larvae production, and one for the more adult stage, using food waste that we would, theoretically be able to get quite easily in the local area in Greenwich. So things like bakery waste, waste from a microbrewery, old fruit and vegetable from supermarkets and bakeries. So that's the first project. As I say, not a lot of impact in terms of its potential to result in transformative change in the food system. There's slightly more impact if you could develop the findings into policy brief. Unfortunately, we found that in most cases the commercial fish feed was better than the so-called sustainable alternatives, which is interesting in itself. The second piece of work stems from another cost action that I'm involved in, which is called NexusNet, which looks at the nexus between water, energy, food, and ecosystems. And this piece of work is about policy, really, and drawing up recommendations for what are called technical screening criteria thresholds for including agriculture in the EU taxonomy. I'll explain in a second what that is. So in terms of leverage points, this would come sort of somewhere in the middle of the hierarchy, because it deals with changing the rules of the system. It could potentially, shape incentives and requirements and constraints under which agricultural businesses operate. There is potentially scope for it to address deeper leverage points, so more transformative ones, if it were to sort of fundamentally shift the goals of the food production system. So, for example, maximizing yield to prioritizing ecosystem health. So what the EU taxonomy is, it's a regulation that came in 2020, developed to define and standardize what qualifies as an environmentally sustainable economic activity. Part of the purpose is to get rid of some of the greenwashing that goes on. Part of the purpose was to sort of direct incentives for investments to be made in sustainable economic activities. And the regulation has 6 environmental objectives: climate change mitigation, climate change adaptation, sustainable use and protection of water and marine resources, transition to a circular economy, pollution prevention and control, and the protection and restoration of biodiversity and ecosystems. So basically, economic activity is considered sustainable if it makes a substantial contribution to at least one of those objectives, and at the same time does no significant harm to any of the other objectives. And there's also a requirement to meet some minimum social safeguarding. So that's things like protecting worker rights. So before the regulation was published in 2020, there was a technical expert group working on this, and they included recommendations for how agriculture should be included, which basically revolves around keeping the objectives of good quantitative status and good chemical and ecological status of water, as defined by the Water Framework Directive, and something to do with nitrogen balance on farms to protect ecosystems. But as yet, agriculture has not been incorporated in the taxonomy, and it's 2025 now, so we're 5 years down the line. The reason for this, according to the EU, is that they need to do some alignment with the discussions going on around the common agricultural policy, and they consider it to be premature. Anyway, so with someone else from the Nexus Net Cost Action, we thought this was a good opportunity to come up with recommendations for how agriculture should be included, what the technical screening criteria should be, what the sort of thresholds should be. But looking at it from the water, energy, food ecosystem nexus perspective, not just from the point of view of protecting biodiversity or safeguarding water sources. So this nexus is actually quite crucial to the transformation of food systems, because it recognizes the deep interdependencies between these sectors, which tend very much to be managed in isolation. Agriculture obviously is the largest consumer of fresh water, and energy is needed for water extraction, irrigation, and food processing. And of course, all three, water, energy, and food, are underpinned by ecosystems which regulate water flows and support biodiversity and maintain soil health. So essentially, this is what we're working on, thinking about how we can make recommendations based on this holistic perspective of the water, energy, food ecosystems nexus. And then finally, the third project, which stems from this TransformERS cost action, is looking at epistemic injustice in food system transformation research. And this, I think, has the potential to target some of the deepest leverage points, specifically, the power to transcend paradigms and the goals of the system. So the project has a number of research questions. first of all, what is the dominant discourse about food system transformation in Europe, in both in the academic literature and in policy literature? Who's dominating this discourse about food system transformation? Where are they? Where are those that they cite located? What discourse about food system transformation is the EU promoting through its funding calls? Which countries are getting most EU funding for this kind of research? What's the composition of the research networks that are being funded? In particular, what's the position of researchers from widening member states and candidate countries in these research networks? And are there any alternative discourses about food system transformation that are not being heard? So, excuse me, adopting a mixed methods approach using bibliometric analysis, social network analysis, and discourse network analysis. So currently, Tamara is working on a virtual mobility, helping me with this, and there's been one previously. It's quite a big piece of work, so it'll take some time to complete. But ultimately, as I say, I think it can help to address some of the deeper, more transformative leverage points. Epistemic injustice critiques the dominant paradigms that shape whose knowledge is valued and whose is marginalized in food systems. And by challenging these paradigms, such as the privilege of scientific or Western knowledge, directly addresses the underlying assumptions and worldviews that drive this system. And this can also open up new ways of thinking about what constitutes valid knowledge in terms of food system transformation. This is the deepest leverage points, because it enables questioning and moving beyond current paradigms altogether. And potentially also this research can help to change the goals of the system, by prioritizing justice and equity and inclusion of diverse voices in shaping food futures. So those are my three research topics. I hope I haven't overrun my time too much, but yeah, once I start talking about this, I kind of get carried away. So okay.